Okay, so let's do the question six. So question six is saying find the amplitude, period, and vertical slash horizontal shifts of the following functions, then sketch at least one full period of each graph. So for part A, they gave us that y equals to tan of 2x minus 1. Okay, just by looking at this, there's a couple of things that we can see. The first thing that we can see is that there's a 2x inside, so which means that there's going to be a different period. So we know that the formula for period equals to p equals to 2 pi over b. In this case, b is just 2, so period equals to 2 pi over 2. The 2's cancel out, so the period equals to pi. We can also see that there is a coefficient of 1 in front of tangent of x, which means that the amplitude is just 1. So far we have two pieces of information. There is only one thing that usually confuses people. We know that for sine and cosine, the generic formula is a sine of bx plus c plus d. This is the generic formula for sine and cosine. But what confuses people is that in sine and cosine, this is considered a vertical shift, not a horizontal shift. But when we're doing tangents, this is considered a horizontal shift. So in this case, there is going to be a horizontal shift of -1. And then there will be a vertical shift of 0. Okay, the graph is going to be very similar to the original tangent of x graph that we already know, but the main difference is going to be the fact that we have a 2x inside, so that's going to change the amplitude, the period by half, because it's going to make it pi instead of 2 pi. I'll just show you the graph of the function. We're going to notice that it's basically the same graph but cut in half when compared to the 2 pi. This is the graph of the function. You can see the different periods over there. We have pi over 8 and -3 pi over 8. These are just 2 points that show you how this is different from where the period is just 2 pi. Okay, for the second part we have y equals to cosine of x minus pi over 2. Okay, there's one main difference between the graph of cosine of x that we can see, which is the fact that we have a minus pi over 2, and by looking at the generic formula, which is a cosine of bx plus c plus d, we notice that there is a phase, a horizontal shift in this case, and to find the horizontal shift we basically take what's inside and solve for x. So x minus pi over 2 equals to 0. We're solving for x, add pi over 2 on both sides. So x would just equal to pi over 2. And this is the horizontal shift. Okay, so now we have one piece of information. The period is just 0 because the period is just 2 pi because b is just 1. So period is 2 pi. And then with we can see that there is no vertical shift. And that the amplitude is just 1 because the coefficient of cosine of x minus pi over 2 is just 1. And this is it for this function. It's the graph of this function is going to be basically the exact same graph for cosine of x, but shifted pi over 2 to the right. So this point is going to be there, this point is going to be over here, and this point is going to be over there. I'll just show you a quick picture of the graph. Here is it. It's exactly what I showed you a second ago. Okay, so now let's do the third part of this question, which is part C. Y equals to 3 sine of 2x. So y equals to 3 sine of 2x. By looking at the generic equation, which is a sine of bx plus c, we can see that there's two main two things that stand out. One, that a equals to 3, so the amplitude two is that b equals to 2, which means that there is a different period than other than 2 pi. So to find that, p equals to 2 pi over b, and in this case b is just 2, so 2 pi over 2, so the period is just pi. These are the two main differences. There is no vertical shift, equals to 0, and the horizontal shift equals to 0. And that's it for question 6. We'll do question 7 and 8 and 9 on the next question, on the next video.